Okay, in this video, let's talk about section 9.2, the law of sines. The law of sines. In the section 9.1, we studied the right triangle. Now in this section, let's assume this triangle is not a right triangle. Assume that the triangle is not a right triangle. Called oblique oblique triangle. Oblique triangle. What is oblique triangle? If it is not a right triangle, it's called oblique triangle. Okay, oblique triangle may have three acute angles. All three angles acute, or two acute and one obtuse. Angles. So oblique triangle either it looks like this, it's oblique, all three angles are acute, or it looks like this. This is obtuse, and the other two are acute angles. Okay, so that's a oblique triangles. To solve an oblique triangle, to solve an oblique triangle means to find the length of its sides and the measurement of its angle. The measurement of its angles. So how do we do that? We shall need to know the length of one side. So we need to at least know one length. This is a fixed requirement. And then along with there are several cases. Case 1, two angles. One side, two angles. Case 2, one angle and one other side. And case 3, the other two sides. Okay, so first we need to know at least the length of one side, and second we just add we just have two angles, or maybe one angle one side, or maybe no angle other two sides. So those three cases gave us four possibilities. There are four possibilities. Case 1. This one. you know one angle, one length, two angles. One length, two angles. You know two angle, actually you know the third angle. If you know two angle, you know all three angles because the sum of three angles is 180 degrees. So two angles will determine the third angle. So what we know is that possibly you will have, you see, you know this angle, you know this angle, you know this side, assume we know this side. So you will have ASA, the side, one side two angle, one side two angles. One side two angle, you will ASA. Or you know one side this angle and this angle. Or SAA. SAA. But SAA actually is ASA because once you know these two angles, the third angle is known. Okay, that's the first case. First case corresponds to the first situation, and second case. Second case we have, you see here, you have one side, one other side, and angle. So you have two sides plus angle opposite one of them. The angle opposite one of them. What does it mean? It means two sides. Let's see, two sides. This one side, this the other side. S. And angle opposite to one of them. If it's opposite to here, it's like this. See, the angle A is opposite to the side S. Or if it is opposite to the other side, it's here. Right? So opposite one of them. All right? So either way, you can read it like SSA or SSA. It's like SSA. So this is a case of a second situation. Why I say it's a case of second situation, not the total second situation, it's a following. So two side plus the angle included, and the included angle. What is the included angle? Included angle means you have this side, you have this side, you know this angle. The angle formed by those two sides. This is SAS, side angle side. So S is a side, A is the angle. This is the other case of the second situation. Second situation, they only require you to know two sides, but they didn't give you the relative position. So there are two possible ways. Either this angle is formed by these two sides, or the angle is not formed by those two sides. Case 4. Case 4, you don't know any angle, just know side, three sides. Three sides, we call it SSS. So we have 4 different cases to solve an oblique triangles. 4 different cases to solve the oblique triangles. Okay, so that's a general discussion. Okay, next let's talk about the law of sines. What is the law of sines? Let's check it. Assume we have this triangle with all acute angles. Let's choose a base B. And this side is A, this side is C, and this is opposite A, angle A, this angle C, and top is angle B, of course. And then we draw the height. We draw the height. Height, H, is orthogonal to the base. Okay, so the height gave us two right triangles. We have a oblique triangle, but this height gave us two right triangles. It's like you cut it. In the left-right triangle, height is the opposite of sine. So the opposite over hypotenuse, A is a hypotenuse. Opposite over hypotenuse is a sine C. And in the right triangle, H is the opposite of A, angle A. So H over C, C is a hypotenuse. H over C is a sine A. Right? So from this, these two right triangles, we get H over A is sine C, H over C is a sine A. We multiply this by A, we get H equal to A sine C. We multiply second equation by C, H is a C sine A. So H can be represented by two different expressions. And then you divide this identity by, equation by A times C. You divide it by A times C. You cancel A, you will get sine angle C over side C is equal to sine angle A over the side A. Here you cancel C. So this is a part of the law of sine. And this formula comes from the computation when you consider B as a base and you draw the corresponding height H and you compute H from the trigonometry. If you consider C as a base, you draw the corresponding height, you will get the relation about angle A and angle B. So the law of sine is that sine A over side A is equal to sine B over side B is equal to side C, sine angle C over side C. See, it's a very neat formula. And of course, here we know that A plus B plus C is 180 degrees or pi radians. So these two formulas are the basic formulas for a general triangle. A general triangle, not necessarily a right triangle. Okay? And this long identity actually contains three steps. One, the short one is like this. You just pick up two terms, they equal to each other. So you consider A and C, it's like this. If you consider A and B, it's sine A over A is equal to sine B over B. Or if you consider the B and the C, it's sine B over B is equal to sine C over C. So it contains three different equalities. All right, so now let's try to do examples. Let's first do SAA. What is SAA? So we know this angle is a 60 degree, this angle is a 40 degrees, and we know this side is a 4. So SAA is in order, in whatever, clockwise, counterclockwise, that's not important, but it has to be in order, the side angle and the next angle. Okay, so let's, this side is called B, this is C, this is angle C. Okay, so let's check. By the sum ABC is 180, so angle C plus 40 plus 60 is 180. So we get C is a 100. No, not 1. 80 is 80 degrees. So this is 100. 180 minus 100 is 80 degrees. So C is 80 degrees. Okay, so by this simple subtraction, we know C is 80 degrees. Then let's apply the law of sine. We know that sine A, where's A? A is here. Sine 40 degrees over the corresponding side 4 is equal to sine B. 60 degrees over the corresponding side B is equal to sine C. C is which is 80 degrees over the corresponding side C. All right. Okay, so now let's just separate them. So if we consider this first two terms, we know sine 40 degrees over 4 is equal to sine 60 degrees over b. This is number b. So you solve for b, you get b is what? B is 4 times sine 60 degrees over sine 40 degrees. And you leave it like this. You leave the answer like this. Don't simplify it. Okay? So this is a B. And C, for C, you choose the first and third term. So you get a sine 40 degrees over 4 is equal to sine 80 degrees over C. So C is 4 times sine 80 degrees over sine 40 degrees. That's it. That's a C. So see here, what do you know? You know SAA, you know 3 quantities. You already compute other 3 quantities. There are total 6 quantities. So you finish the solution. So SAA can be completely solved. SAA can be completely solved. You know the concrete solution. Now let's talk about SAS. SAS is similar. For example, the angle here is 15 degrees. Here is 35 degrees. This is side B. This is angle C and side A. So you know 15, you know 35. Side angle C plus 15 plus 35 is equal to 180 degrees. So C is this is 50, 130 degrees. So you get the angle C equal to 130 degrees. And then you list, you state the law of sine. Law of sine A is a 35, so it's a sine 35 degrees over the A side. What's A side? I don't know. Put A. And the sine B is a 15 degree angle B over the side B. And the sine C is 130 over the side C. So it's a law of sines. And then you pick up the first and the third. Sine 35 degrees over A is equal to sine 130 degrees over 5. You solve this inequality for A, you get A is 5 times sine 35 degrees over sine 130 degrees. Right? So this is the second solution. And the final one, let's talk about the B. B, you just pick up sine 15 degrees over B is equal to sine 130 degrees over 5. So B is 5 sine 15 degrees over sine 130 degrees. That's a B. Okay? So we find the answer. In the exam, don't simplify it. Don't simplify. Okay, so let's talk about SSA. SSA. So first, let's draw one angle, A. we place one side horizontal, then we draw the angle A. Then on the terminal side, you select a segment, you call it B. And then you see here your A. So remember this SSA, so you have this side, you have this side. If your given data A is too small, if your given data A is too small, what I say is too small, because your angle A is already formed. So when you pick up one side B here, so this point is fixed. From this point to the initial side of A, the minimum distance is B times sine A. This is a minimum requirement for the length of the triangle. So if this B sine A is greater than A, if this provided number is smaller than this height, there's no triangle. Which means with the data letter A, B, and angle A, you cannot construct a triangle, zero triangle. Okay? And second case, if your side A happens to be the height, then there is exactly one triangle. There is only one triangle. Okay? And if you, okay, this one is like this. That's exactly A. If your side A is longer than this B times sine A, then you can place the A either to the left side or to the right side. So if A is longer than B sine A, of course A should be less than B, then there are two triangles. There are two triangles. You can either place it this way, get one triangle, or you place this bigger one and get the second triangle. Okay? And the final case, if this A is very, very, very long, longer than B, longer than this B, then you have to place it on the right side. There's no way for the left side because it's too long. Here it means too short. The first case, too short, no triangle. Second case is if it's too long, you can only put it on the right side. If it's in the middle, then you have two possible ways. There's only one triangle. So the SSA will have several sub-cases. Okay? So for example, we solve the triangle A is 3, B is 2, and angle A is 40 degrees. So angle A is 40 degrees. Angle A faces opposite angle side A. Angle A opposite side A. So this has to be B. Is equal to 2. A is greater than B. A is greater than B. It can only be placed here. If you place on the right side, it will be on the. If you place it on the left side, it will be too long. So it can only be placed this way. All right. So A is greater than B. There is one triangle. One triangle is like this. Now let's try to determine all of them. We know that sine, this is B, angle B, this is angle C, this side C. Sine A is a 40. Sine 40 over A is a 3. Is a sine B over B, B is 2. So sine 40 over 3 is equal to sine B over 2. So from here you know that the sine B is 2 sine 40 over 3. Alright? And then you take the inverse. So B is sine inverse of 2 sine 40 degrees over 3. This is the B. This is a B, and then when you have B, you can have C. The C plus B is and plus A plus 40 degrees is equal to 180 degrees. So C is 180 minus 40 and minus sine inverse. Alright, so this is C. And when you get the C, you can determine the side C, because sine A over A is equal to sine angle C over side C. A is 40 degrees, so you get a sine 40 degrees. Side A is 3. This side is 3. And it is equal to sine C. Sine C, this long expression is 140 degrees minus sine inverse of 2 sine 40 degrees over 3. C, no, yeah, C is this, and over C, side C. And then from here you solve for C, you will get C is 3 sine 140 degrees minus sine inverse of 2 times sine 40 degrees over 3. And over here we use the sine 40. Alright, so this is the side C. So you have 1, you have 2, what else? And B, angle B, 3. 1, 2, 3. You know three conditions. You're looking for the rest of the 3 quantities. The total is 6 quantities. Alright? So this is one solution because A is too long. And there are 2 possible solutions. What are the 2 possible solutions? Let's check. So assume the side A is 6, side B is 8, and angle A is 35 degrees. So you first draw the angle 35 degrees. This angle is 8. And then you get, besides it is 8, B is 8. And then you have A equal to 6, so first of all, A is greater than B times sine A. It's 8, not 8, 6 is greater than 8 times sine 35, my bad, 35 degrees. This verification has to be done by the calculator. Without a calculator, I don't know what is the sine 35 degrees. Assume we know this. So this is a slightly bigger number. So you will have two possible positions. Either you place this a slightly longer stick on the right side or on the left side. So there are two solutions. There are two triangles. You can form two right triangles. Okay, so for example, let's form the first one. Okay, so from here, this is A, this is B. So sine A over A is sine B over B. Sine A over A is sine B over B. And from here, this is B. It's a C. From here, we know that the sine B is B over A. B is 8. A is what are going to be? Okay, B is 8. A is 6. And the sine A. So we just move B to the left side. It's B over A. B is 8. A is 6. So it's 4 over 3 times sine 35 degrees. This is a past. This is a sine angle, and this sine angle, I don't know the B is a acute angle or obtuse angle, because acute and obtuse angle both give us sine positive. So sine B, let me copy it here, equal to 4 over 3 sine 35 degrees can give us two angles. One angle, you just to make it acute. It's one angle. Or the other angle, we make it obtuse. You use 180 minus this acute angle. Once again, without a calculator, I don't know what this is, what degree it has, but I do know B is either this or this. So when B is this one, it corresponds to this. If B is this one, it corresponds to the obtuse angle. So this is obtuse angle. Obtuse. This is acute. Okay, so this is obtuse case. Acute case is obtuse case. This is obtuse case. This is acute case. Acute case. Obtuse. This is acute obtuse. Yes. So there are two possibilities. There are two possibilities. These two possibilities comes from this condition. When A is slightly bigger than the height, if it is equal to the height, so there's no extra space. If it is bigger than the height, so you have to either place this way or you have to place this way. Okay, right? So originally the height is this, so you just put it here. It fits the space. Or if you extend it, so you have to either write this way or write this way to place the third side. Okay. We can also have the no solution case. So we assume A is 2, B is 1, and C is 50 degrees. Okay, so you first draw the 50 degrees, and you get B equal to 1. Oh, C is 50. Sorry, it's not B, it's a C. C is 50, C is 1, B, A is 2. Then this is a C equal to 50 degrees. This is side C. A is here. Side C faces angles. I don't think so far. So side C faces angle C. So this is not side C. This is A. C is here. But remember that from this point, this A is equal to 2. From this point, this hypotenuse is 2. So the height is 2 times sine 50 degrees. 2 times sine 50 degrees. This is a height, but your stick is too short to touch the floor. So C is smaller than 2 times sine 50 degrees. If it's too short, cannot touch the ground, then those data cannot construct a triangle. So there's no solution. There is no solution for this situation. It's just because this segment is too small. Segment is too small. Okay? C faces angle C, A faces angle A, B faces angle B. All right? So only for SSA case, SSA situation, it has several cases. Any other situation, you just get a unique triangle, oblique triangle. Okay, so now we have a mountain. We want to measure the height. So we do the following trick. So first, a person stand here. And then the person look at the peak of the height. There is an angle. It's a 35 degrees. And then the person move to the second position. And the person look at the angle, the mountain peak again. And then there is a height. (47 degrees). And between those two positions, the distance is 900 meters. Okay? See what we know? We start from one position. We observe the peak. We measure the angle formed by this eyesight and the horizontal line. And then they move 900 meters to the second position and look at the peak and measure the angle of the eyesight and the horizontal direction. It's 47 degrees. With these two conditions, compute the height of the mountain. What is the height of the mountain? All right, this is the stuff. Now let's try to understand it. So we have an obtuse triangle, this one, obtuse triangle. And this side is a 47 degrees, this angle, and this angle is 133 degrees, right? The sum is 180. So you use 180 minus 47, you get 133 degrees. And one side is 900 meters. So you have an angle, side angle, ASA. So this is an ASA problem. For ASA problem, let's check what we want. We want this height. This height is in the big triangle or in the small right triangle. But in the bigger right triangle, you have more information, okay? Because you have a side, you have two angles. In a small right triangle, you only know one angle, nothing else. It's not enough, okay? So let's check. In this bigger right triangle, I know one angle. If I know the hypotenuse, I can compute the height. What is the hypotenuse? Hypotenuse is this side. This side faces 133 degrees. So let's call this side C. And let's call this base B. So this is angle B. So first of all, angle B plus 35 degrees and plus 133 degrees is 180 degrees because those three angles belong to the same triangle. Okay, so from here we get B is what? 12 degrees. Is this 12? Yes, it's 12 degrees. So 900 meters faces 12 degrees in this obtuse triangle. So what we get a sine B over 900 meters is equal to sine 133 degrees over the side C. Then we can solve for C. We get C is equal to 900 times sine 133 degrees over sine 12 degrees. In the exam, leave it like this, okay? In the exam, leave it like this. This is not a final answer, but you cannot simplify it. Okay, once you get the C, you consider the bigger right triangle. Hypotenuse, you know the hypotenuse, you know the angle. So H over C is a sine 35 degrees. Opposite over hypotenuse. Opposite of over hypotenuse. So H is C times sine 35 degrees. Then C is here. 35, sine 35 is that answer. So it's a C 900 sine 133 degrees over sine 12 degrees and times sine 35 degrees. This is the answer. Okay, this is the answer. Don't ever simplify it. Don't. All right. Okay, let's see another word problem. Okay, let's try to understand this word problem. So there's what's this? It's a C bank, and there's a ship. There are two stations. Station 1 Zulu. Station 2 X-ray. And they can observe the ship this way. And those two stations are 120 meters. Here, this angle is a 50, this angle is a 60. Okay, so this is a graph. Let's see the problem. The Coast Guard station. The Coast Guard station Zulu is located 120 miles west of station X-ray. A ship sends an SOS call that is received by each station. Okay, they both receive this SOS call. The call to Zulu indicate that the bearing is N40 east. Okay, N40 east, check here. This is N. 40, you rotate 40 to the east. So this is 40 east. So that's why here in the graph you see 50. 40 plus 50 is 90. Okay. The call to X-ray is N30 west. So this is 30. Because you have N30 west, you rotate to the west, you turn to the west. Okay, so 30 west. So you have 50 and 60. Okay, now we have several questions. Question 1, how far is each station from the ship? So basically what they ask you? They ask you what is length of this side, what is the length of this side. Let's call them, this is A, this is B. Then what do we know? This is 50, this is 60, the top is 70. 70 angle faces 120 miles. B faces 60 degrees. So you get sine 70 degrees over 120 miles is equal to sine 60 degrees over B. Then you get B is equal to 120 sine 60 degrees over sine 70 degrees. This is B. Don't simplify. And if you want to compute A, then you get a sine 70 degrees over 120 is a sine A faces 50 degrees over A. So A is 120 sine 50 over sine 70. Okay, so those two are the distances. Don't simplify. And if a helicopter capable of flying 20 miles per hour is dispatched from the nearest station to the ship. How long will it take to reach the ship? Okay, so first it says nearest station. It doesn't say which station. You have to determine which station. Then you have to really compute this angle. You will see that sine 60 is bigger than sine 50. So A is shorter. Shorter means near. So So you're going to start from the X-ray. The distance to X-ray is shorter. So you get the distance divided by the speed. So you have this 120 sine 50 degrees over sine 70 degrees and divided by 200, which is format. It's a 12 over 120 over 200. It's 1200 over 200. You cancel 40, so 3 over 5. So it's a 3 over 5 times the sine 50 over sine 70. After such hours, the shape, the helicopter will reach the ship. That's how. Okay. So again, here I don't use any calculator. I just want to tell you what is estimated, what is the correct full answer you should write in the exam. Okay. Of course, in the textbook, you check that the textbook give you the estimation. Estimation depend on the calculator, which you cannot use. All right. So do the exercise of this section, the law of sines, and try to solve some triangles, oblique triangles. Understand the process. Send me email if you have question. We stop this video. Thank you.